Okay, my friends, get ready because I am going to make some outrageous claims. And like my old boss used to say, it ain't bragging if it's true. And I am going to be bragging like hell, and it's going to be true. Okay, my friends, here's where we're starting. Today, 20th of December, 2023, new measurement of the Higgs boson is the most precise ever recorded. You see that? That's a Higgs boson. Let me tell you about Higgs bosons. And again, I'm going to be bragging. Take it for whatever you want to take it for. This is just facts. Okay, if you're at all interested in this, you probably already know about Higgs bosons. Here's the deal. It says when streams of ultra-fast protons and neutrons come around and they smash together and collide, a Higgs boson pops up, instantly goes away. Every now and then. Very, very few of them, though. In that moment, physicists can work backwards to estimate the mass of what could be the most important and yet most elusive particle in a standard model. Listen to this. The most important and yet most elusive particle in a standard model. It's not elusive at all. It might be important, but it sure as hell ain't elusive. Okay, the best place to start is the beginning, and this is in about 2012. They decided they had found these Higgs bosons, and this is a simulated artist rendition of these circular patterns. Now, since then, they have discovered more and more of them, and this is their latest concept of the Higgs boson. It says when streams of ultra-fast protons collide. So here they have protons or neutrons. They have both, and they smash together like that. There might pop up for existence for a brief second. Okay, my friends, here's what I want to show you. This is the standard model, and the Higgs boson, they claim, gives rise to all these other particles. I say no. Those other particles give rise to the Higgs boson. Remember these words. They're taking ultra-fast protons. They go around and around and around and around, and bam, they hit like this. And when they collide, a Higgs boson might pop up into existence for a brief instant, and then it decays, they're saying, into lighter particles. In that moment, physicists can work backwards to estimate the mass of what could be the most important yet most elusive particle in a standard model. The most important and the most elusive. Well, it's not elusive at all. It could be important, but they have it completely backwards. The Higgs boson does not decay into lighter elements. Lighter elements make up the Higgs boson. All right, so this is from Atlas or CERN or Fermilab. They all have the same thing. They know they can see these patterns, but they see them in a whole pile of debris because they're smashing these things together. We use light, so we use particles this small. They use particles this big, and they get a whole pile of debris, and they dig through it literally for years to find the smallest particles. They found them, but they're meaningless because they have the total wrong concept. This Higgs boson does not decay into other particles. This Higgs boson is the product of other particles coming together. And can I prove that? I absolutely can. All right, don't forget, now this is what they see at CERN and Fermilab and all of them. And it's the same thing here. They see these big balls of debris and then some circles in there, which are the Higgs bosons. And this is now they claim, wow, we can really see them now. They did a bunch of upgrades at CERN, and I'm going to tell you why they did them in a minute. Now, this is the standard model right here, and they say the Higgs boson decays into the W and the Z bosons. No, absolutely wrong. The W and the Z bosons come together to make the Higgs boson, which ends up being a particle. It doesn't decay to that. The two decayed particles come back together to be what they should be, is the Higgs boson. All right, don't forget, this is just crazy. It really is. They have no idea what they're even looking at, and it's the most precise ever recorded. Every time I read these things, the next thing you say, well, it's all different than we thought. The mass is totally different than they expected. And they admit it. They just keep coming up with all kinds of things. These discrepancies aren't resolved. The latest measurements are the best estimates. They're guesses. And then it goes on and on and on, just say all kinds of wiggle room for the data. Well, no, there isn't. You can see the particles. I'm showing them to you. And then they can say there's a few possible, the fissures in the standard model. I guess so. They're fissures, I guess. And here is a standard model. The W boson's mass was out by 7 standard deviation from the model predicted, a result no one expected. They have no idea what they're doing. None, zero. Because they're working with these gigantic particles. They should start with light, which was what we started with, and we can watch the particles develop. Want to see them develop? Sure you do. Okay, here's how it develops. This is a pulse red laser. Light is light. It doesn't matter if it's laser or it's regular light. It's supposed to go the same speed forever. This is pulse, pulse, pulse. There's a particle inside here, and I'll show it to you. All these gases and so forth that are in the air have to get a little bit excited because they're getting pushed out of the way as this comes through. Field against field makes things glow. All right, watch this. That's that same particle in that same field, only we're putting it through a venturi, which forces it to accelerate. And it's pulling its own particle out of its own magnetic wave. Normally there's a big field surrounds every tiny particle, so that you got the field, which creates a wave, and then you got the particle. That's why I always said particle or wave, they don't know. Well, it's both. The field surrounds the particle, and this is now the particle. Can I show you what that particle's like? Absolutely. What does it do here? It creates muons and electron showers. And right here is your Higgs fields. Okay, the only reason they're seeing the Higgs fields is because when they smash their huge particles and they get all this debris, they will break apart some of these photons and separate them into their black and white particles, and then when they come back together, that's when you get the Higgs. Here it is right here is the particle that we saw coming out of the wave. Now remember this particle, and over here is where it explodes. Let me go back to the other way here. Right here, remember, that's where the particle is here, and the wave surrounds it because it's a magnetic field. You saw the black and white particles. That means it's a dipole. That means it has a magnetic field, just like a bar magnet. So as they come through the air, they have this big field surround them. Everything gets pushed out of the way. That's why everything glows. And then all of a sudden it accelerates like crazy because of the venturi. Now, remember there was a black and a white. I think I showed you that. All right, here they are back to back. It's like 2 bar magnets. That is a photon. Half of that is an electron. So a black and a white on its own is called an electron or a gluon. And that is where the dark matter is. They never knew it because it's part of light, but it's the dark side of light. It's really the carrier. So this is red. Can I show it to you in other colors? Yes, I can. Here's a green, same particle, no difference whatsoever, identical same particle. And it creates, these are neutrinos just before it becomes a photon. And the same thing with this right here. I can show you the neutrinos. See that? That's a neutrino, and it turns into a photon. It doesn't have quite the same mass as a photon does. Or do these over here. These are also photon-ish neutrinos. They're going to end up photons if they bounce off of something. Well, these ended up photons before they bounced off because they are accelerated now and actually glowing exactly identical to what a photon would look like. And then they split here into the muons and electron neutrinos, which are these particles right here. I just showed you the muon electron neutrinos. Let me show you what they show from Fermilab. Okay, so these are the particles they were looking for from Fermilab, and they found them. They found these, but they just were in debris, and they do exactly what I say they do as well. That has all the mass, and it is literally dark matter, and that has no mass and is all the energy. And then they talk about the standard model, and then they talk about the quantum foam, which I agree is all fill space. Empty space isn't empty. It's full of all these particles. Light is a particle. That's all I can tell you. Okay, so you have seen the particles. You've seen how they normally come light. This is acceleration. There's no other way to understand it. And it also splits the particle here and it fuses back together over here. And in the middle is raw electrons. That's the electron side of the dipole. So in the middle here is only the white. You see the white and the black? The black can't get through. The white goes through the Venturi and the black can't get through. So that's what we're looking for, is this electron showers. You see the black can't get through, only the white. And they turn into showers. Exactly. This is from CERN and Fermilab and all the rest. These are the muon neutrino is the black one. The electron neutrino is the white one. The two of them together normally are stuck together. Now the muon takes off on its own, all by itself, and the white one turns into a shower because it's very, very energetic, and they hate each other, and they're being forced into this Venturi, which is an extremely tight restriction. In CERN, they hit them head on, so they're causing the same sort of effect. They're crushing the fields. They're crushing them this way. We're crushing them sideways. No difference whatsoever. Only we can direct them into actually squirt them right onto a substrate, which will absorb that white energy and give us free energy, I believe. And here's exactly how I would say to do it. Shoot the laser through that Venturi, put your collector right there, send your white stuff down into your battery or wherever you want to use it for. And you can carry these things around in a little lunchbox because they're self-contained, solid state, no danger whatsoever. You're working with light, and all you're doing is separating out the white particle. When you do a solar panel, that's all you're doing, the exact same thing. You got a solar panel here, and you're collecting whatever electrons can be liberated. Now, with us, they're just there's nothing but electrons. But with a solar panel, you're catching one over here, a couple over here every now and then, but certainly nothing like that. Okay, so that's my little rant there. But anyway, this was from Fermilab, the people I dealt with. Here's what happened. I'm going to tell you the whole story. I might as well tell you the whole story. When I had this stuff, I figured this all out. I saw this stuff. I get a hold of Fermilab. Don Lincoln, this was his baby, was these Higgs fields. They were trying to find him back in 2013, 2012, somewhere around there. I got a hold of him. I said, Don, I found the particles. He said, no, those aren't the right. You're just guessing, and those are interference patterns or some nonsense he came up with. And I said, no, these are the same particles you found, and we used light, and here's how I did it and everything. And we went back and forth, and finally he said, don't ever contact me again. You're a tinfoil hat guy. And I'm serious. That's exactly what happened. And I am showing him the particles that he had, and I understand why he did this. I destroy their funding. They are sucking money out of our economy like it's water, and they're not even trying to do anything. If he wouldn't look at this after what I showed, it's a disgrace. And I'm still to this very day pushing like crazy. I even went to the University of Geneva for particle physics, and guess what? I showed them these particles, and they were blown away. I reacted with them. I said, your problem you got with CERN. And I told them, this sounds like I'm a crazy guy, but they didn't fight. I said, the problem you got, you're not focusing. You're sending these particles around, and they're just hoping something's going to hit each other. I said, you got to focus them really tight, like we're doing here with a focus. You got to focus, and then you got to use CMOS to see the reactions. Complementary metal oxide silicates is what you use in your cell phones. But they're made for light particles. They're not made for big chunks. What happens is when they send things around, they hit them, and then they get chunks like this. You can't photograph that. It will destroy your CMOS. And I had a guy just the other day was trying to do some experiments with a very high-powered blue laser, and it did destroy the CMOS. He ruined his cell phone. I said, I don't know. All I can tell you is a cell phone is made to see light. And this is what this particular Galaxy S3 from 2014, this phone, and this is what Rod used. I use the same one. And we use the selfie side to take the pictures. And what pictures? These pictures, right, of light. And here's the light right here. When it came through, when you look at this, I showed you this right here. All right, the light is accelerating, It's exploded here. The white is separated from the black. That's fission. It comes back together here. What does it look like when it comes back together? It's Higgs fields. They say the Higgs fields decay into these two particles. No, these two particles make the Higgs field. You want to see it happen? I can show you it happen. Remember, we're talking about the brightest bright white coming through here. And we got it one focused. It's focused like a laser beam right here. There's the white, white, white. And here's the Higgs fields. Why are the Higgs fields there? They're not decaying. They're being made. The black particles are just laying around, and they're just laying around. And when the white hits them, they turn into these little patterns. Those are the Higgs fields. Now, they think the Higgs fields somehow are there, and then they decay into the white and the black particles. Just the opposite. The white and the black particles come together to form the Higgs. You see that? That's the white coming right at us. In here, all you got is white. As soon as they start smashing into the black ones at that distance out, they turn into the Higgs. This one here is a reverse spinner. That's the only one I've ever seen like that. And that's spinning backwards and gathering a field into itself. And then it collided with one of those and made the strangest thing I've ever seen. And if they want to start looking for strange things, look at this. Look at that. Here's what's happening. When those white particles come out and they hit the black, they spin. They spin into these platters. And the outside, it appears to me that the outside is where the particle sits. And somehow it forces these fields to grow inward. Normally they grow outward, but I'm not going to get into that right now. However, what's happening is they are spinning. The white particle is spinning this way. The other white particle is spinning this way. So this is the one, that little one that I showed you, I believe, and I'm not even positive that, I'm pretty sure, but this was the white one that I showed you in that last shot, and it's spinning in this direction. It should be spinning in this direction, so it's going backwards. And what happened? As it hit this field, it started to manifest its own backwards field, and then the particle sitting at the edge here is stripped off by this particle coming this way. So this particle coming this way, and this field hitting it with its particle going that way, this grabbed a hold of that particle and ripped it right off. And it's headed off that way for I don't know where. But that right there, my friends, is a mystery. You see this? I told you I went to the University of Geneva, and I told them all about our stuff. And I told them about using CMOS. And they said, you can't use CMOS because it gets destroyed. And I said, no, you have to use CMOS. You just got to harden it somehow and filter it so that you don't get these big chunks hitting you. All you get is the little particles. Like we started with the little particles. We never have to worry about the big particles. So what they did was they shut down CERN for 3 years. Now, I'll take credit for it because I told them about our research. You got to focus, which they did. They put in focusing magnets and they put in CMOS hardened to see it. And this was a 3-year shutdown. They came back online in 2022. After 3 years shutdown, Large Hadron Collider smashes particles together at the highest energies yet. It's still terrible compared to us. We can do billions of times better than they can for a few dollars. They're spending billions of times more money and getting a few particles. It's just a scam at this point because they should fully understand by now. I've saturated everybody with this. And CERN, University of Geneva, they were impressed. I don't care what anybody says. They were impressed. They said, wow. And I said, well, can we work together? And they said, no, we'll follow you on Facebook. And I said, you got to be kidding me. Can't we do something? And they said, no, we'll follow you on Facebook. And that was it. Those were the professors. I worked with them at University of Geneva. Nobody wants to get involved in this because they want to use the big protons. Well, the big protons turned out to be what they're looking for is that. Why not start with that? It's insanity. It's just nothing more than a money grab at this point. You see that? This is the Higgs coming out here. You got a blue one and it's converting. This is pinching. You see the two particles are coming in on the side, pinching that field. So that field is being crushed and it's gaining energy, turning blue. That's something else should be looked into. This should all be red. This should all be red, but that didn't do it. And now they're asking all these questions about the Higgs now, and I have a lot of the answers. All right, here it is right here. Even wilder wonderings include, are there different versions of the Higgs, which I just showed you, yes there are, that we've not yet discovered, and could the Higgs be a portal to understanding dark matter? It's half of dark matter. When the white comes back to the dark matter, it turns into the Higgs. The mysterious stuff that fills the universe, but which no one has ever seen. Yes, you just saw it a second ago. Of course, physicists are still on the hunt for other particles that might explain the Higgs boson's incredible lightness. No, the Higgs boson is when it comes back together and becomes a particle. When it separates, it becomes one particle that has no weight whatsoever that I can find, and one that is all the weight. All right, so of course physicists are still on the hunt for other particles that might explain the Higgs boson incredible lightness, an anomaly that has dogged them since the Higgs was discovered in 2012. And here's what happened. 2012, Don Lincoln from Fermilab was assigned to trying to find these Higgs. Well, in 2014, 2015, I had found the particles he was looking for and showed you, well, here it is, just one more time. This is what he was posting. These were the particles that they had found, the smallest particles. This is 2013, this is. And about 2014, 2015, it might have been end of 2014, early 2015, I contacted him. I said, here's your particles. Here's the glowy, the black one with the glowy edge, and that's exactly what he says. And there it is, the black one with the glowy edge. And this one is the white one that gets puffy and small and has no mass. That has all the mass. And he's exactly right. All right? But they didn't know what they were looking at, because they're using these gigantic particles, the protons, and they're seeing just nothing but debris. We actually see that particle turn into the stream and then separate the black from the white. I've shown it to you, and if you didn't see it, I can't understand how. Okay, back to this. See, since 2012, we're trying to find these Higgs. Oh, we're trying to figure out why they're so light. With recent upgrades to the LHC now complete, this is 2022, they're getting back online, designed to increase the energy and intensity of its particle collisions, and more upgrades planned in the future. Who knows what will emerge? You don't have to know what will emerge. It's already emerged. Why won't somebody contact me? I have been hitting the all of them, all the universities, Fermilab, Atlas, CERN, Lawrence Livermore, 100% of them. And not a single response, not one single response other than Don Lincoln saying, don't ever contact me again, you're a tinfoil hat guy. And they are spending billions and billions and billions of your money. And they refuse to look. It was right in their face. It's a disgrace. And when I said I'm going to brag, I am going to brag. They would have never done this if they didn't know when I showed them about being able to use the CMOS and focusing. And in 2022, they came back online. They're still only finding just a handful of particles colliding. Just a handful. Trillions and trillions and trillions of dollars they've spent over the course of these last 50 years trying to find and even figure out how gravity works. They're never going to understand anything until they understand that all the particles there are dipole electrons. And when you add them together, they don't make one gigantic proton like this. They make a ball of particles which can be separated. And that's the only reason, the only possible reason hydrogen can explode. How could one gigantic proton and one little tiny electron explode with such enormous explosions if it was just one of these and one tiny particle? It's just, well, how are you going to make that thing explode into a bazillion pieces? It's already a bazillion pieces. You just have to add a little extra electrons in there, and then it says, I'm no longer stable, and pew, they all go. And you get an explosion. It'll knock your brains right out of your head. You see, feedback at sciencenews.org. I'm going to send them my stuff. And I have never had a single response from any of these people. The only thing I ever get is, you're an idiot, stay away. Although when I first started, I was showing this stuff to people and they were impressed. They said, you got to talk to Don Lincoln over there at Fermilab. He's the Muon guy. He's the, Higgs guy. And I said, well, I tried talking to him and he told me to get lost. And they said, well, that's because you, Roger, are an idiot. Okay, my wonderful friends, let's sort of wrap this up. I know a lot of you are taking physics or have people that you know that claim to be physicists or highly intelligent in this light realm. Well, I suggest that you show them this and say, what's going on? What's the problem? Why don't they look at this from the people that are supposed to be doing work for us? Fermilab specifically is the worst of them all. And this is very, very obvious what I'm showing you. And this is their huge, huge breakthrough. We can see these things. This is just an artist's rendition. And they got smashed particles coming everywhere, all over the place. But they have seen these fields. Now they really know what's going on. All we're using is light. And we got fields coming out of our ears. And we can focus them in just like this. We could put a harvester right there, and once they hit back to the black particles, then they just become back to particles that are black and white together. There is no separation of the particles to speak of normally. The only way you can separate them is an atomic bomb blast, or what they're doing over at CERN, or like us, putting it through the Venturi. It's as simple as that. We just did it very, very simple. And there it is right there. Acceleration, no question Einstein was wrong about this. There's the particle, and it is a wave because of the magnetic field. Here it is, that's fission, that's fusion, and this is raw energy. This is stuff that you put in your car to drive. And this is what we need right now. And being told I'm a tinfoil hat guy by the people that we hired to try to find a solution is a terrible disgrace for Fermilab. Absolute disgrace. And all the rest of them too. Not one of them would respond. So Fermilab's the worst because everybody pointed me towards them. And I said, well, they won't talk to me. I tried to sort of buffer it a little bit. Well, I've sort of had it. But, what could you say? They won't talk to me. And then I got the same thing from them. Everybody else, you're an idiot. That's why they won't talk to you. Why do you think they won't talk to you? That's the kind of response here. Why do you think they won't talk to you, Roger? Gee, maybe it's to protect their status and their funding, Mr. Expert. Very, very annoying. This whole system of science now sucks. Thank you. Have a wonderful Christmas. I love you all.